Hey guys, I wanted to go over the problem you just looked at. You were asked to graph y equals x squared plus 2x minus 3. And these are some of the things we've already covered. So the first thing to do, I actually needed to do my work, like just like you are doing your work in your notebook, I have to do my work on a piece of paper. So I showed you that here, so I'll stop the screen so you can see it bigger. Okay, so here's the equation. Sorry, let me fix that. Here's the equation. Y equals x squared plus 2x plus 3. The first thing to do is find the axis of symmetry. So remember, the axis of symmetry is where it cuts the parabola in the middle. And you find that by x equals the opposite of b over 2a. And we have to remember where these numbers are coming from. Our a is coming from, it's the coefficient of x squared. Our b is the coefficient of x, and that c value, while very important, is not used for the axis of symmetry. So the opposite of b, my b value is positive 2. So the opposite sign would be negative 2 over 2 times a. So a, if I don't see it, that means there's only one of them. So that's why I put a 1 there. And then we do the denominator first. 2 times a is 2. Negative 2 divided by 2 is negative 1. So that's my axis of symmetry. So if I go back to my graph and graph just that part, so I'm going to graph a vertical line at x equals negative 1. So I like to do the axis of symmetry in red. So at negative 1, I'm going to draw like a dashed line. Now, mind you, I know that. Same for you. You're using draw it on here. So, you know, it's not the easiest, but there's my vertical line, which means the parabola is on half on one side, half on the other. So the vertex could be anywhere on this line. So now I got to find the vertex. I do that because I already know my x value. All I got to do is plug it in. So going back to my work, step 2 is find the vertex, plug in x into the equation. So your equation is x squared plus 2x plus 3. That's actually a minus 3. I fixed it there, but not there. You know this. I know this. Ignore. Okay, so all the work luckily reflects the right problem. So now we plug in negative 1 into the x for the equation. Here we go. Plug in negative 1 into the x. I do negative 1 squared plus 2 times negative 1 minus 3. Negative 1 squared is 1. 2 times negative 1 is negative 2 minus 3. And then go left to right. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. If you're using a calculator, you can put it in all at this step here. Okay, and so the vertex, we already knew our x value from our axis of symmetry was negative 1. So all we needed to add was the y value, which is why I put a blank here. So our vertex is negative 1, negative 4. So now going back to the graph, I'm going to plot a point at negative 1, negative 4. Since I already have my axis of symmetry there, it should be on that. And look, the green dot, that's my vertex. So now I just need to find more points than that. We do know our y-intercept, so that's something we could certainly plot. Our y-intercept is that c value. So that's negative 3. So I could definitely plot that point here. And then how far away is negative 3 from the line? It's 1 away, so I should have a reflection point on the exact opposite side. But this is not enough to graph this problem, because if you look at the bottom, it says identify the x-intercepts. So I need to know exactly. I could draw a graph, but I don't know, maybe I draw it too wide, right? So what I want us to do is to plug in points, make a table of values, plug in points, and get the other 2 points. All right, so my table of values here, I have 5 spots, typically, and my vertex goes in the middle spot. So negative 1 was my x, negative 4 was my y, and then I'm just gonna pick integers that are bigger than negative 1. So like 0, and 1. That looks like an O more than a 0. 0 and 1. You guys get the gist. And then -2 and -3 are on the opposite side. Now I already did the math. I plugged in 0 into all parts and I got -3. I plugged in 1 into all parts, did the math, and I got 0. On the other side, I plugged in -2 and I got -3. I plugged in -3 and I got 0. So if you notice, look at the y values: 0, -1, -3, -4, -3, 0. So it shows you that there are a reflection, right? Around that vertex, you have the same y values in the distance. Okay, so now I'm going to plot these 5 points and I'm going to hope that I pass my x-axis so I know my x-intercepts, because that's what I need, right? Oh my goodness, I have the 3 middle points already plotted. So let's add the other points. I'll use my lovely blue. I've got -3, which is right here. Oh, still orange, whatever. And then I have 1, 0. That's right here. So now I can draw my curve. Now I'm changing it to blue though. There we go. So now I can draw my curve. I know it's a U. It's not that easy to do on here. I get it. Oh no. So that part was really hard. So I would like to fix that. Right? So just keep that in mind. If you do make a mistake, like, you can fix it. Oh, that's too small. All right, I don't want to waste our times by being a perfectionist. But, you know, I should have done this better. You get better with Nearpod as you use it. I'm sure you guys feel the same way with everything in life, right? The more we practice, the better we'll be. Okay. So let's try that again. I know there's like leftover blue, but I'm doing my best. Okay, and I continue to rise on both the left and the right, so I drew those arrows there. So now I graphed the function, great. And the other thing was to identify the x-intercepts. Oh, okay, so my x-intercepts are, I'll use the red, are right here and right here. So I'm going to write it like this: x equals, and this is where I could have used -3, comma, 1. Okay, so those are my x-intercepts. That's what it equals. And that's how you did this problem. That's how you should have done this problem. Okay, great job today. Continue through.